Hi, students. Good evening. Happy New Year to you. Welcome to this video session. My name is Samuel Dominic Chukwu Emeka, aka Sam Dom for Peace. In this video session, we shall continue our discussion on normal distributions, normal probability distribution. And specifically, we shall solve several applications of normal probability distribution. It is highly recommended that you have read the notes and viewed the videos on a normal probability distribution before you begin this assignment. And as we normally do, we shall just use technology to solve the questions. We are going to use the calculators on my website and the Pearson Statcrunch. If you are using a TI 84 Plus, you can check out the tutorials on my website on using TI 84 Plus to solve the questions. Keep in mind that the TI 84 Plus probably will solve some of these questions. Okay, so let's begin. Question 1. And as it's pulling up, as question 1 is pulling up, I can go ahead and use the calculator on my, I can open up my website. So let me open it on a different browser. Let's go to my site. I will select the mobile friendly site. So I type my first name, last name, AppSpot. And you can get this under statistics, or you can also get it under portfolios. You can get this calculator under statistics resources. You can also get it under portfolios. We are going to use a probability distribution calculator. That's what we will use. And then we shall also use the Statcrunch. So I think we are going to do some questions with my calculator, and we'll do some questions with Statcrunch, so I can show you both of them. Question 1. Pulse rates of women are normally distributed with a mean of 77.5 beats per minute and a standard deviation of 11.6 beats per minute. What are the values of the mean and standard deviation after converting all pulse rates of women to z-scores using that formula? So when you convert to z-scores, that is the standard. Z-score is also known as the standard score or standardized score. That means you're now ready to use your standard normal probability distribution table. And the standard normal table, or you can just say standard normal distribution table or standard normal table. The standard normal table has a mean of 0 and a standard deviation of 1. Okay, standard deviation of 1. So the original pulse rates are measured with units of beats per minute. What are the units of the corresponding z-scores? Z-score has no units. We mentioned that if you go to my notes, If you come here and you click notes and videos, well, the z-score says z-score is unitless. Z-scores, it has no unit. Okay, and if you, the normal distribution is also here. If you look at the notes, you will see normal probability distribution. So it doesn't have any units. That's one of the characteristics of z-scores. It's unitless, does not have a unit. Okay, so it is highly recommended you have looked at all these. So z-score are numbers without units. Yes. Question 2. Find the area of the shaded region. So this is, of course, I have explained, I've done in another video how you read the table. So these videos here, I will just use technology right away to, to save time. So it's important you read the notes and view the videos on these topics prior to doing the assignment. So I'm not going to use these tables because I have done videos on how to read the table. So I'm just going to use my calculator. That's what I'm going to use. I'm going to click on a normal distribution. Let me see, drag this here a little bit. I want this to be on the same, like I want it to, I want both screens so you can see it. Actually, I don't need this. I don't need this one, that screen. So I just need these 2 screens here. Okay. I hope you can see this well. I hope so. All right. So this is they're asking us for the area of probability, and the variable is 90. So you just come here, and they give us the mean and standard deviation. So I'm gonna the variable is 90. The mean is 100, and the standard deviation is 15. And you can press the enter key or you press calculate. So I listed both, the less than and greater than detailed. With my calculator, I try to make things detailed as much as I can. So this is less than the area to the left. Okay, so area to the left. And this will give us to 4 decimal places is 0.2514. Okay, less than that. Question 3 is between, area between. Area between. You know what? How about I use my calculator, then we do Statcrunch. I use my calculator, we do Statcrunch. I use my calculator, we do Statcrunch. How about that? Okay, so this between, if you're using, you can just use this one right away. This is between. You use this here. But let me use Statcrunch. So go to question help, you go to Statcrunch. Okay, and let me shift this Statcrunch here so you see it. So I click on start, I click calculators, I click normal. So here is between, the area between. Okay, the probability between these scores, which is the area between the scores. So the probability that 90 is less than or equal to x less than or equal to 125, and that is the area between the scores. So you go to here is less than and greater than. If you click here, this is less than, this greater than. That's the standard here. You don't want this though. Go to between here. Go to between, and you put the mean. The mean is 100. Standard deviation is 15, and you want the probability between 90 and 125, and then you press the enter key. So it shows you that, and this will be to 4 decimal places is 0.6997. Okay. Here is another case between. Let me close this, or let me just leave this. I still need it. Let me use my calculator this time. How about it? My tongue. So this is x1 is 102, x2 is 130, the mean is 100, and the standard deviation is 15. Enter. So my calculator even gives, like this one is the between here. This is what you use. Like with this case, my calculator gives a detailed result. But this is the particular one you need to use here, this one. Okay. Now this one is known as away from. In some questions, in some textbooks, they ask away from. But this is what they're asking right here. So this is 0.4255. 0.4255. Okay. This one is asking for the x. They gave you the probability. That's the area to the left, and then it's asking you for the x. So this time is Statcrunch turn. So where's the Statcrunch? Okay. So in this case, it's not between, it's to the left. Go to standard, and the mean is 100, the standard deviation is 15. So they're asking for the x in this case, and they gave you the, and this is the left, so you leave it as less than or equal to. And they gave you the probability already, which is the area. So you put 0.75, and you can press compute or you press enter key. It doesn't matter. Okay. So to 1 decimal place, this is 110.1. This one, they ask you the same thing, but they gave you area to the right. So my turn. With my calculator for this, where they are asking for the x, the variable, because they gave you the probability and you have to find the variable. So just scroll down to inverse normal, and you use this if you're using your TI 84 plus, inverse normal. And as you go there, you use this one, because here they gave you the right. They gave you the right area to the right. So we use this. So we put in the mean. The mean is 100. The standard deviation is 15. And the probability is 0.8. Okay, press calculate. And you see that the x is 87.4. That's the x. 87.4. Okay. Okay, Statcrunch turn. Assume that adults have IQ scores that are normally distributed with a mean of 105 and a standard deviation of 20. Find the probability that a randomly selected adult has an IQ less than 125. Okay, they're just asking you for probability. So you just put 105 here. The mean is 105. Standard deviation is 20. And they're asking you for less than, IQ less than 125. Enter. To 4 decimal places, that would be 0.8413. Okay. Question 8, my turn. My turn. Assume that adults have IQ scores that are normally distributed with a mean of 105 and a standard deviation of 20. Find the probability. So they're asking for probability. They're not asking for the score, the z-score or the variable. No, they're asking for the probability. So you only use the inverse normal distribution if they're asking for the z-score or the value of the variable. But if they're asking for the probability, you have to use this here, normal distribution, normal probability distribution. Then this one is another section. Another section we're going to use this particular one. But for this section, you use this. So find the probability that a randomly selected adult has an IQ between 94 and 116. So we're going to use between, and that is here. So I'm just going to put 94 here, 94. I put 116. Those are the two boundaries, the lower boundary and upper boundary of the IQ scores. The mean is 105 and the standard deviation is 20. And you press calculate. So this is what you need here, this particular one here. Between. My own calculator gives several detailed results. As you can see, I wrote detailed here. Okay, so you just have to be careful which particular one to use. But don't worry, you're gonna appreciate my calculator. If you're in some textbooks, like away from is this one. Okay, in some textbooks where they ask a lot of more parts, questions that has children and grandchildren, then you appreciate my calculator more. But this is still nice though. Just know the one actually to use. So this is 0.4177. So we put 0.4177. Okay? Statcrunch. Question 9. Assume that adults have IQ scores that are normally distributed with a mean of 100 and a standard deviation of 15. Find the 9th percentile. 9th percentile. So they want you to find the IQ score that separates the bottom 9% from the top 91%. So either way, they're asking for the z, not the z-score, the variable score, the IQ score. So you can use either, I'm going to show you with either way, so it will give us the same result anyway. So we use less than 9% to the left or 91% to the right. It gives us the same answer. So this is what you do, folks. The mean is 100. We put it, standard deviation is 15, and 9% to the left. 9% is 0.09, so 0.09, okay, and press compute. So the answer is 79. To the nearest 100 is 2 decimal places. So the answer is 79.89. That's the answer. So this is the 9th percentile, okay? That's the lower 9% from the upper 91%. Now, another thing you can do to get the same answer is you can go and you put greater than here. And once you put greater than, you see this is 91%. It still gives you the answer, 79.89. Or even if you come here and just put 0.91 and press enter, you still have 79.89. Okay. So either way gives you the answer. Yeah. Either you put this and this is 0.9 and you press enter. 9%, 0.09, I mean 0.09, yeah, and you press enter. So the answer is 79.89. Okay. Is the IQ score. Okay. Question 10, my turn. In this case, it's the same question, but they want us to find a third quartile. Like, is this? They're still asking the same thing. They just change the values. Here, the mean is 107, and the standard deviation is 15. And they want us to find the third quartile. Now, remember, the third quartile is the 75th percentile. So they want us to find a score. So you have to use the inverse normal distribution. And with mine, I'm going to show you both ways, okay? The third quartile is 75th percentile, which means it is the score that separates the lower 75% from the upper 25%, okay? If you divide it into 100 parts, the third quartile separates the lower 75% from the upper 25%. And if you divide it into 4 parts, which of course is the quartiles, then the third quartile separates the lower 3 from the upper 1. So the mean is 107 and the standard deviation is 15. In this case, it's lower 75%, which is 0.75. Okay. So the variable is 117.1. And if you want, we can still get the same answer, 107, because this one is the left, lower part, and this is the upper part, right? So 107.15, but for the upper part to the right, we have to put 0.25 and then press enter. It still gives us the same thing. See that? Gives us the same thing. So the third quartile is 117.05. Okay? Oh, to 1 decimal place, so 0.1. Okay? All right, Statcrunch. Question 11. A survey found that women's heights are normally distributed with mean 63.6 inches and standard deviation 2.3 inches. A branch of the military requires women's heights to be between 58 inches and 80 inches. A. The percentage of women who meet the height requirement is what? So percentage is also probability, okay? And this is the requirement. They have to be between 58 inches and 80 inches. So we're gonna put between here, between. The mean is 63.6. Standard deviation is 2.3. And the percentage between, or the probability between 58 and 80. Then press enter. If you convert this to percent and you leave it in 2 decimal places, it is 99.25%. 99.25%. Okay? Next question. Are many women being denied the opportunity to join this branch of the military because they are too short or too tall? The 99.25% meet the requirement. So it's just very few. Only very few do not meet the requirement. So the answer is no. So you eliminate options A and D. You look at B and C. Okay. So B says no, because only a small percentage of women are not allowed to join this branch of the military because of their height. Yeah. When you allow this is a high percentage. So only a small, only 0.75% do not meet the requirement. So that's very small. Okay. For the B, if this branch of the military changes the height requirements so that all women are eligible except the shortest 1% and the tallest 2%, what are the new height requirements? Okay, so in this case, they are not asking us for the probability or the percentage or the area. They are not. They are asking us for the score. The height is the score, is the variable in this case. They are asking us for the value of the variable. Okay, the value of the variable is a better syntax to use, a better word to say. We are not dealing with IQ scores. We are now dealing with height requirements. So the variable is the height, and they're asking us for the value of those heights, the new heights. But the shortest 1% will not be eligible, and the tallest 2% will not be eligible. Excuse me. So we're going to back to standard here. Click standard. And the mean is 63.6. The standard deviation is 2.3. Good. Now, the shortest 1% is 0.01. Okay, that is the probability. Now we want to find the actual value. So you're going to put the 0.01 here. To find the value, you put compute. Okay, so that is 58 to one decimal place will be 58.2. So I'm going to put 58.2 here. And then the tallest 2%. So I will come here, I will change this to greater than or equal to, and I'm going to put 2% is 0.02. The tallest 2%. To find the actual height. Okay. So the boundary here will be 68.3. So what this means is that those that are shorter than 58.2 inches and those that are taller than 68.3 inches are not eligible. Okay, the people that are now eligible are the women who are at least 58.2 inches and at most 68.3 inches. So any woman that is shorter than this height or any woman that is taller than this height is not eligible. Okay. Question 12, my turn. A survey found that women's heights are normally distributed with mean 62.2 inches and standard deviation 2.6 inches. The survey also found that men's heights are normally distributed with a mean 68.5 inches and standard deviation 2.8. Inches should be there. Inches should be there. Okay. You always want to put your units. Always. So that must be a little typo. Okay. A, most of the live characters are at an amusement park. Most of the live characters at an amusement park have height requirements with a minimum of 4 feet 9 inches and a maximum of 6 feet 2 inches. Find the percentage of women meeting the height requirement. So this is they're asking us for the probability. That's the percentage. And we're going to use between. So go back to here. And we're going to use this between. The bounds, the lower bound here is 4 feet 9 inches, and upper bound is 6 feet 2 inches. Because uh, the mean, they gave us the mean is 62.2, and the standard deviation is 2.6 for the women. Okay, because that is what they asked for the women. But these scores here, the boundary scores, okay, the lower bound and the upper bound, or you can say the boundary heights. We are going to convert this to inches so we can make sure everybody has the same unit. They gave us feet and inches. So we're going to convert this to inches. And you know that 12 inches make 1 foot, so you can do the conversion. But I'm just going to, I have a measurement calculator here. I get to portfolios, measurement and units calculator. I'm just going to do this to be faster. Any conversion. Just going to go to any conversion. So I'm going to put 4 feet, 9 inches. 4 feet plus 9 inches. 4 feet plus 9 inches. And I want this to inches. You just type it like this, okay? 4 feet plus 9 inches to inches. You can add or subtract any conversion at all. 4 feet plus 9 inches to inches. Calculate. So this is 57 inches. I'm going to come here. Where is that calculator? Normal distribution. So the first one is 57 inches. And I'm going to go to the next one. 6 feet 2 inches. 6 feet plus 2 inches. And you can convert this yourself, okay? Calculate. So this is 74 inches. Sometimes JavaScript still has this funny thing of putting a lot of, decimals. So rather than give you the exact one, they give you a lot of decimals. But this is just 74 inches. So I'm going to use 74. This means 74 inches. So this is the other value. And you just press calculate. Okay. So the between is actually this here. And this is a 97.72%. 97.72%. If you convert it to percent. 97.72. Okay. Then find the percentage of men meeting the height requirement. So I'm just going to change the mean and standard deviation for the men. So for the men, the mean is 68.5. The mean is 68.5 and the standard deviation is 2.8. And then I just press enter key. So this will give us 97.498. So 97.50%. 97.50%. Okay. See, if the height requirements are changed to exclude only the tallest 5% of men and the shortest 5% of women, what are the new height requirements? Okay, so I'm gonna go to, because here they're asking us for the height, the variable. So they're not asking us for the probability. They're asking us for the variable. So we use inverse normal distribution. And in this case, the tallest 5% is to the right. Tallest 5% of men is to the right. I'm gonna use this here. And shortest 5% of women is to the left. Okay, so let me start with this. For the tallest 5% of men, So this means to the right is 0.05. 0.05. And I use the mean for the men. The mean for the men is 68.5. And the standard deviation for the men is 2.8. I press enter. So I have this. Let me keep it first. The shortest 5% for the women is to the left. So this is 0.05 is what I'll put here. I use the mean for the women, and that is 62.2 inches. And the standard deviation for the women is 2.6. Okay, calculate. So we see that the new height requirements, you see that now. Okay. The we have to arrange it in order. The new height requirements must be at least, and that is to one decimal place. So at least 57.9 inches, and at most 73.1. Okay, if you round it well. All right. Question 13. Statcrunch. Men's heights are normally distributed with mean 68.7 inches and standard deviation of 2.8 inches. Women's heights are normally distributed with mean 63.5 inches and standard deviation of 2.5 inches. The standard doorway height is 80 inches. A. What percentage of men are too tall to fit through a standard doorway without bending? And what percentage of women are too tall to fit through a standard doorway without bending? Okay, so they're asking us for the probability. Make sure it's in standard. Let's do the men first. Okay. So for the men, the mean is 68.7. The standard deviation is 2.8. And the normal, the standard doorway height is 80. So you come here, you put 80. You want to leave it because this is too tall. Okay, so you don't do less than. You want it as greater than. All right. You don't want less than. You want greater than, because they're asking for too tall to fit through. Compute. So this is essentially two decimal places. This is 0. Okay, so just put 0 here. 0. Then for the women, you just change the values here. The mean for the women is 63.5, and the standard deviation is 2.5. And you just press enter. For the women, as you can see here, it's still 0. Still 0. So you just put 0. Okay. Then the next question, if a statistician designs a house. Now, let me say this about the women. This E, because some students ask me, what is this E? Well, this means 2.0558 times 10 to the negative 11. That is what it means. This is in a scientific notation. Okay, in scientific notation, 2.0558 times 10 raised to exponent negative 11. That is what it means. So it's 0.000000000. You know, you count how many zeros. Let's count it. This actually means 0.0000000. 0, 0, 0, 0, 0. Should be 11 zeros. Let's do it again. 0 0.0 0 0 0 0 0 0 0 0 0 0 20558. So it's 0%. Okay. So that's what it means. Now the next question: if a statistician designs a house so that all of the doorways have heights that are sufficient for all men except the tallest 5%, what doorway height would be used? So in this case, they're asking us for the variable, the value of the variable, and the tallest 5%. So that's for the men, not the women. So we get this back to the men. For the men, the mean is 68.7, and the standard deviation is 2.8. And we want the statistician wants to design it so that what was the statistician do with the design? wouldn't it be an engineer? That's fine anyway. So to exclude the tallest 5%, so we make sure this is greater than or equal to, and you just put 0.05 here. Okay, 0.05. We are looking now for the height of the doorway. What is the new height of the doorway? So you make sure you put greater than or equal to 5%. Enter. So the new height will now be to the nearest 10 means 1 decimal place. So that will be 73.3. Okay. All right. Question 14. My turn. A common design requirement is that an environment must fit the range of people who fall between the 5th percentile for women and the 95th percentile for men. In designing an assembly work table, the sitting knee height must be considered, which is the distance from the bottom of the feet to the top of the knee. Males have sitting knee heights that are normally distributed with a mean of 21.3 inches and a standard deviation of 1.2 inches. Females have sitting knee heights that are normally distributed with a mean of 19.7 inches and a standard deviation of 1.1 inches. What is the minimum table clearance required to satisfy the requirement of fitting 95% of men? So in this case, we asked for the value of the variable. So we're going to use the inverse normal distribution, and it has to fit 95% of men. So that is lower on the left. You use left 95%, 0.95. Okay, because it has to fit that 95% of men. So is the lower 95%. So this is 0.95 will be the probability, and the mean for the men is 21.3. The standard deviation for the men is 1.2. Okay, 1.2. You press calculate. So the minimum variable to 1 decimal place is 23.3. 23.3. Okay. Determine if the following statement is true or false. If there is a clearance for 95% of males, there will certainly be clearance for all women in the bottom 5%. let's see this. Why don't we first why don't we do for women bottom 5%? Why don't we do that? So uh, we bottom 5% means top 95%. Because I want us to check side by side. I really want us to check side by side. So we can. I don't want to. I still want this fig. I have the figure 23.3. Okay. So let's do for women bottom 5%, 0.05, and the mean for the women is 19.7 inches. The standard deviation is 1.1 inches. Okay. And we have 17.9. So, of course, it's going to fit that. And you can, and I just want to show you though, you see this 23.3 is greater than 17.9. But even if you don't look at it that way, like I just wanted to do this, but even if we don't look at it that way, if you look at it with the normal curve, 95% is way beyond 5%. Okay? It's beyond that. It's beyond that. So there will certainly be a clearance for all women in the bottom 5%. Yes, it's true. Yes. Okay? And it's because 95% is greater than the 5% for women, of course. Even if we, as we did it, 23.3 is greater than 17.9. But even if you didn't do this, if you look at it from the normal curve, you will see. Although it's better that we did it, so you kind of see it yourself that the 23.3 is greater than 17.9. Okay, so yes, it's true. Okay. The author is writing this exercise at a table with a clearance of 23.9 inches above the floor. What percentage of men fit this table? So here we are looking for the probability. Okay, so we're gonna use probability. And we look at the x in this case is 23.9. The mean, and that is for the men. The mean for the men is 21.3, and the standard deviation is 1.2. Then press enter key. So as you can see here, the percentage of men that will fit the table will be, to two decimal places, will be 98.50%. Okay, 98.50% will fit the table. Okay, as you can see from here, if you convert that to percentage, so 98.50%. Now, what percentage of women will fit this table? We just need to change the mean for the women, and that is 19.7. Standard deviation for the women is 1.1. Enter. This will be 99.99. Okay, as you can see here, this is 99.99%. 99.99%. Okay. Does the table appear to be made? Does the table appear to be made to fit almost everyone? 98%, 98.5% of men fit the table. Then 99.99% of women fit the table. So I think the table will fit almost everyone. except about 2% of men with the largest sitting knee heights. Yeah. Uh, with the women, is almost all of them. They are at an advantage with the design of that table. Uh, the men would be about 2%, because this is 98.50%. 98.5 is about 1.5% uh, would would not be would not be comfortable with the table. Would not. It's not because they have a large sitting knee height. So it's about 1.5%. But yeah, they said about 2%. That's fine. Uh, it will fit almost everyone except about 2% of men with the largest sitting knee heights. Yes. Okay, Statcrunch. The lengths of pregnancies are normally distributed with a mean of 270 days and a standard deviation of 15 days. Find the probability of a pregnancy lasting 309 days or longer. So the mean is 270 and the standard deviation is 15. So the X here is lasting 309 or longer. They're asking us to find the probability. So this is 309 or longer, so you make sure you use greater than or equal to. Don't use less than or equal to, use greater than or equal to. And this is a 0.0047. 0.0047. Okay? B, babies who are born on or before dash days are considered premature. So B, if the length of pregnancy is in the lowest 4%, then the baby is premature. Find the length that separates premature babies from those who are not premature. Okay, so lowest 4%. Okay, so we're gonna use this. We're gonna change this to less than or equal to. And we need lowest 4% is 0.04. We put it here because they're asking us for the variable, not the probability. They gave us the probability already. And you just press compute. So this means that babies who are born 243.73971 days. Nearest integer. So babies who are born 244 days are premature. Okay? 244 days are premature. Okay, my website, my calculator. Question 16. Assume that human body temperatures are normally distributed with a mean of 98.18 Fahrenheit and a standard deviation of 0.62 Fahrenheit. A hospital uses 100.6 degree Fahrenheit as the lowest temperature considered to be a fever. What percentage of normal and healthy persons would be considered to have a fever? Does this percentage suggest that a cutoff of 100.6 degree Fahrenheit is appropriate? B. Physicians want to select a minimum temperature for requiring further medical tests. What should that temperature be if we want only 5% of healthy people to exceed it? Such a result is a false positive, meaning that the test result is positive, but the subject is not realistic. Okay. A, they're asking us for the percentage. They're asking us for the probability. The normal and healthy persons considered to have a fever. and then round to 2 decimal places as needed. The mean, so we're gonna use this here. We'll use this. The mean is 98.18, and the standard deviation is 0.62. Oh, I didn't. 98.18. Okay, here that's the mean, and standard deviation is 0.62. All right, what about the x? The x is the 100.6. 100.6. Okay, calculate. So what percentage would this is the lowest temperature. The lowest temperature considered to be a fever. Okay. So as you can see here, what percentage of normal and healthy persons will be considered to have a fever? Well, in this case, it's like because this is the percentage less than that, less than that. So it's 0. Okay, you're going to be looking at this one here because it says here a hospital uses 100.6 as the lowest temperature considered to be a fever. What percentage of normal and healthy persons would be considered to have a fever? So if this is the lowest, this means actually that it's less. These are the percentage that has less than 100.6, and this means it's just 0. You just put 0 here. Okay. Does this percentage suggest that a cutoff of 100.6 degree Fahrenheit is appropriate? As you can see here in that question, in this question, if they are normal and healthy persons, right, that means they don't have, like, they are normal and healthy. That's the first thing that should come to your mind is, okay, these people are normal and healthy, right? So that tells you that, okay, they don't have fever. That tells you that they don't have fever. So you're gonna look at it that way first. And you see it's 0% also. So I think that's a reasonable cutoff, because from normal and healthy persons, that means 0% of normal and healthy persons have fever. That's what this is technically saying. So I would go with C, option C. Yes, because there is a small probability that there is the probability is 0 actually. So it's 0. So there's a small probability that a normal and healthy person would be considered to have a fever. Would be considered to have a fever. Some of these questions actually you have to use your reasoning. It's kind of practical. You have to use your reasoning. B, physicians want to select a minimum temperature for requiring further medical tests. And what should that temperature be if we want only 5% of healthy people to exceed it? So in this case, they are asking us for the variable. We will use inverse normal. 5% would exceed it. So we're going to use right of 5%, 0.05. Okay. Now let's put the mean. The mean is 98.18. And the standard deviation is 0.62. Okay. Enter. So for only 5% to exceed it, which means 5% to the right, then the temperature, the minimum temperature would be 99.20, and that is to 2 decimal places. Okay, 99.20. Okay. All right, Statcrunch. Question 17. Assume that the Richter scale magnitudes of earthquakes are normally distributed with a mean of 1.097 and a standard deviation of 0.541. Earthquakes with magnitudes less than 2.000 are considered micro earthquakes that are not felt. What percentage of earthquakes fall into this category? So they're asking us for the probability. And that is less than. Now the mean is 1.097. Standard deviation is 0.541. Okay. The x in this case is 2. 2.000 is still 2. Okay. Enter. So this gives us 95.25%. 95.25%. Okay. B, earthquakes above 4.0 will cause indoor items to shake. What percentage of earthquakes fall into this category? Above 4.0. So we're going to put 4 here, but we put greater than or equal to 4. And that gives us 0. That gives us 0. So 0. C, find the 95th percentile. So 95th percentile means 95 to the left, 95% to the left, or 5% to the right. The 95th percentile is the magnitude of the earthquake that separates the lower 95% from the upper 5%. So we can use upper here, but if we're using upper, we'll put 5%, 0.05. Or we can use lower, it will give us the same thing. Okay, I think I demonstrated it earlier. We can use lower 0.95, okay, and press enter. Or we can use upper, but if we use upper, then it will be 0.05. But let's use lower, 0.95. And this is the answer here, okay. To 3 decimal places will be 1.987. 1.987. 1.987. Will all earthquakes above the 95th percentile cause indoor items to shake? Well, the thing is that earthquakes above 4.0 will cause indoor items to shake. Okay. And all earthquakes above the 95th percentile, what if you have because 95th percentile is 1.987. What if you have 2.5? What if you have 2.7? What if you have 3.4? What if you have 3.9? That is not up to 4. I mean, that is not above 4. So no, the answer will be no. Okay, no. And it's because not all earthquakes above the 95th percentiles have magnitudes above 4.0. Okay, yeah. Question 18, my turn. Engineers want to design seats in commercial aircraft so that they are wide enough to fit 90% of all males. Accommodating 100% of males would require very wide seats that would be much too expensive. Men have hip breadths that are normally distributed with a mean of 14.6 inches and a standard deviation of 1.2 inches. Find the 90th percentile. That is, find the hip breadth for men that separates the smallest 90% from the largest 10%. Okay, so we're going to use inverse normal distribution Uh, we can use lower 0.9 or we use upper 0.1. It will give us the same answer. Okay, so I'm going to use 0.9 lower here, and the mean is 14.6. Standard deviation is 1.2. Okay, enter. So to one decimal place, the answer is 16.1 inches. Okay. Question 19, Statcrunch. Chocolate chip cookies have a distribution that is approximately normal, with a mean of 23.5 chocolate chips per cookie and a standard deviation of 2.5 chocolate chips per cookie. Find the 5th percentile and the 95th percentile. How might those values be helpful to the producer of the chocolate chip cookies? So let's first of all find the 5th percentile. The mean is 23.5. Standard deviation is 2.5. And the 5th percentile is lower 5% from the upper 95%. So 0.05, but to the lower. Okay, so that is to one decimal place will be 19.4. 19.4. Then the 95th percentile is lower 95% from the upper 5%. And to one decimal place will be 27.6. Okay. How will it be helpful? I like chocolate chip cookies, but I think the question should have also said maybe chocolate chip cookies that fall between that range would be considered normal. But you know, chocolate chip cookies, they make people fat. Obesity. And America is a lot of obesity. A lot of obesity. Because they add too much sugar. It's too much sugar. It's too much sugar. Maybe the question would have said maybe the chocolate chips cookies between that range would be normal, and then maybe if it is if it's below the 5th percentile, then it's no sugar, or I don't know. I don't know whether it's in sugary content or something. But I think from the question, I think the idea is that the chocolate chip cookies between the 5th percentile and the 95th percentile are the normal ones. People who eat above the 95th percentile, that would be, will I call it a over obese, over obese or what? But anyway, these are sugary stuff. How might it be helpful? I think the values can be used to identify cookies with an unusually low or high number of chocolate chips, so those numbers can be used to monitor the production process to ensure that the numbers of chocolate chips stays within reasonable limits. Well, let's read these options and see which one. But I think, as I'm looking at it, I think C makes more sense. A, the values can be used to identify cookies with an average number of chocolate chips. So those numbers can be used to monitor the production process to ensure that the numbers of chocolate chips stays within reasonable limits. These values has nothing to do with average, no. Okay, no. The percentiles have nothing to do with average or mean. So A is out. B, the values can be used to identify cookies with an average number of chocolate chips. B is out. C, the values can be used to identify cookies with an unusually low or high number of chocolate chips. So those numbers can be used to monitor the production process to ensure that the numbers of chocolate chips stays within reasonable limits. D, yeah, C makes more sense. D, the values can be used to identify cookies with an unusually low or high number of chocolate chips. So those numbers can be used to monitor the production process to ensure that the numbers of chocolate chips stays below 50th percentile. With D, no, no, no. What about the 95th percentile also? So they asked us these two values, not just one value. And if it stays below 5th percentile, maybe some people would be, some people like chocolate chips. Some people will want a lot of chocolate chips in their cookies. So if they see only one chocolate chip in a big cookie, they might not be happy. If especially, and Americans, they complain. Americans, we complain a lot. We complain a lot. Okay, let's get back on track. B is not the answer because we are considering the two values, and actually, below the 5th percentile should be maybe very low or no chocolate chips per cookie. No, and that's not probably why they asked this question. For them to ask us to find the 5th percentile and the 95th percentile should give us, okay, this should be the range to produce, to ensure that the production is made, that the number of chocolate chips per cookie would be within reasonable limits. Okay, so I think C is the most reasonable choice. Okay. Question 20. I guess this is not with any of the calculators. You guys can finish this, right? Which of the following is not true? A. The area in any normal distribution bounded by some score x is the same as the area bounded by the equivalent z-score in the standard normal distribution. That is correct. If you look at this, if you look at my calculator, you see I wrote it. Okay. The probability that is greater than x is the same probability that is greater than the z-score. The z-score is just converting that x to the standard score so that you can use the standard normal table. Okay, so yes, the area bounded by the x is the same. When you convert it to the z-score, yes, it's the same, it's the equivalent z-score, so that actually you can use the standard normal distribution table. So A is correct. B, a z-score is an area under the normal curve. No. Z-score is not an area, it's just a standardized score for the variable. Okay, it's not an area, no. Area is the probability. So B is not true. C, a z-score is a conversion that standardizes any value from a normal distribution to a standard normal distribution. Yes. It's in my notes. Okay, it's in my notes. Yeah, and I just said it. Actually, you convert to z-scores so you can use the standard normal distribution table. So C is correct. D, if values are converted to standard z-scores, then procedures for working with all normal distributions are the same as those for the standard normal distribution. Yes. So the answer here is B. B is the choice that is not correct. That is not true. It's the correct choice because it is not true. Okay? Question 21. Where would a value separating the top 15% from the other values on the graph of a normal distribution be found? So with a normal distribution curve, please, when you will do the empirical rule is the 68, 95, 99.7% rule. So the total area under the graph is 1, under the normal distribution curve. Okay, the total area under the normal distribution curve is 1. Half of it is 50%. So if you're looking at the top 15%, top, not lower, top 15% will be on the right. Okay, top 15% will be on the right. Remember, the total area is 100% or 1. Half of it is 50%. 50%, the other half is 50%. But they said top 15% from the other values. So that top 15% is gonna be area on the right. Okay, it's top 15% from the bottom 85%, and that will get you on the right side. Okay. What conditions will produce a negative z-score? If it is on the bottom 50%, okay. In the center, the z-score for of course, the mean is 0. For a standard normal distribution curve, the mean is 0, the standard deviation is 1, and at that center, the z-score is equal to the value of the variable. Okay, but if it's going to be a negative z-score, then it has to be below, to the left. Got to be to the left. Is the z-score corresponding to an area located entirely in the left side of the curve? Okay, we don't now remember the area. We don't have a negative area. No, we don't have a negative area. We only have positive and negative z-scores. But the z-score corresponding to the left side of the curve is the negative 1, negative z-score. Okay. Last but not the least, if you're asked to find the 85th percentile, you are being asked to find, of course, the 85th percentile means the score, okay, the score that separates the lower 85% from the upper 15%. Okay, or you can say the bottom 85% from the top 15%. So is the data value associated with an area of 0.85 to the left. Yes, 85th percentile is that score, that data value, okay, the variable, the value of the variable that separates the lower 85% from the upper 15%. So 85% is 0.85. So that's the data value associated with an area of 0.85 to its left. Yes. Okay, that's this. Okay. And after this, you just save it. Okay. Thank you so much for listening to this video session. If you have any questions, please ask. And you have a good evening.